So this problem is a problem where you do partial fraction decomposition. So I'll call this the algebra part. 10 over x minus 1 times x squared plus 9 should be some number over x minus 1 plus bx plus c over x squared plus 9. Bx plus c because x squared plus 9 you cannot factor, and the numerator will be 1 degree less. All right, so I'm going to take this and multiply the whole thing by x minus 1 times x squared plus 9. I'm going to do a lot of that without writing it down. I'm looking at this first fraction. Multiply that by x minus 1 times x squared plus 9. You're going to get 10a times x squared plus 9 plus bx plus c times x minus 1. At this point, I'm going to pick some values for x, like let x equal 1. If I pick 1, that is going to give me bx plus c times 0. So it wipes all this out. And I'm going to have 10 equals a times 1 squared plus 9. So 10 equals a times 10. Divide both sides by 10, and we get that a equals 1. All right, so at this point, I'm going to look at this part and say, now I know that a is 1. Let's put that in there. 10 equals 1 times x squared plus 9 plus bx plus c times x minus 1. Think about a good next step. Sometimes it's one thing, sometimes it's something else. I'm looking at this and I'm thinking, look at that b times x. I can pick x equals 0 next. So let's let x equal 0. And I will have 10 equals 1 times 0 squared plus 9 plus b times 0 plus c times 0 minus 1. So 10 equals, well, this is 9 times, that's just 9. 9 plus b times 0 is 0, c times negative 1. So let's subtract 9 from both sides. 10 minus 9 is 1. 1 equals negative c. So this gives me that c equals negative 1. So I'll put that into the problem. So now from this part right here, we're going to have 10 equals, I'll leave that 1 off. A was 1. X squared plus 9 plus bx, c is negative 1, bx minus c times x minus 1. Oh, I forgot to write. C is negative 1, so that's going to be plus, minus negative 1, minus negative, so plus 1 right there. So I am going to, oh, it is plus c, thank you. Minus 1. All right, so I'm going to probably rewrite this so I don't make a mistake on that minus 1. And so bx minus 1 times x minus 1. I could pick another value for x. I could maybe do some, I'm going to pick another number. I picked 1, I picked 0. Let's pick 2, if x is 2. So this would be 10 equals 2 squared plus 9 plus b times 2 minus 1 times 2 minus 1. So 10 is 4 plus 9 plus 2b minus 1 times 1. Oh, that worked out nice. So that's 13 minus 1. That would be 12. So 10 equals 12 plus 2b. Subtract 12. Negative 2 is 2b. So b is negative 1. Back to the problem. So now we have this. The integral of 10 over x minus 1 times x squared plus 9 dx is equal to the integral a over x minus 1. A was 1. 1 over x minus 1. bx plus c over x squared plus 9. b is negative 1. Negative 1x. c was negative 1. Minus 1 over x squared plus 9 dx. Now from here, actually I talked about this yesterday, I think. When can you split a fraction? Look, I got negative x minus 1 in the top. I can write this as two fractions. The integral of 1 over x minus 1 minus x over x squared plus 9 minus 1 over x squared plus 9 dx. Okay, this part here is going to be a natural log. What about this part? U substitution, and I guess eventually maybe a natural log. This part, that's an inverse tangent, but I probably have to do a little work to get that inverse tangent. Yeah, I do. So this one is a natural log. This one is u sub and then natural log. This one is going to be some inverse tangent. Who knows what it is right off? That's what it's going to be. Yeah, that's what it's going to be. I probably need to show a few details on that. So we'll hold that for tomorrow. And